Math 3, Unit 4, Section A. So today we're talking about simplifying radical expressions. And so most of the time you guys have only seen roots like where it's square roots. But there's actually cubed roots, which would be a third root. And what does it mean when you have something that's a third root? Kind of like that, yeah. And so in order, you know, like with square roots, how if I have the square root of 25, that answer is what? 5. Well, a cubed root would be like 27. So with the square root, you needed 2 of the same numbers. With the cubed root, in order to bring it out, you need 3 of the same numbers. In this case, this one would be 3, 3, 3, right? And so this 3, which is the index, is telling you how many you need in order to pull that out and make it one group. And so this answer would end up being 3. Does that make sense? Yeah? Okay. Now, there are a few things about roots. And that is if n is odd. So if your index is odd, okay, and I might highlight or underline some of these things. If n is odd, there is only one real root. Okay? But if n is even and b is positive, there are 2 real roots. The positive root is called the principal root, and the negative root is the opposite of it. If b is negative, though, remember, and we talked about this last unit, there are no real roots because that would end up becoming an imaginary number. Now, what makes this slightly different is that when n is odd, you can have a negative inside. So, for instance, if we were to do the cubed root of negative 27, there isn't an imaginary number there. The answer would actually end up being negative 3 because negative 3 times negative 3 times negative 3 is what? Negative 3. So the cubed root of negative 27 is actually negative 3 because you have a group of negative 3's. So if n is odd, your answer could just be a positive number or a negative number. Okay? But when it's even under the root, it has to be positive, otherwise it's not real. Is that clear? Kind of? Okay. So we'll kind of go through here. And then the only nth root of 0 is 0. So anytime you're taking a root of 0, it's 0. Because there's no positive or negative zeros, right? Okay. So examples. So it says find the real 5th root. So right now we're doing odd roots of these numbers. So the answer is just going to be positive or negative, correct? And so what this means is we'd write this as the 5th root of 0. And as we just said, any root for 0 is going to be 0. Okay, the next one, we have the 5th root of negative 1. So what would be the 5th root of negative 1? Negative 1. Because all those negative 1. Negative 1 times negative 1 times negative 1. 5 of them will end up making negative 1. Okay, and then we have the 5th root of 32. So what does 32 break down to be? Yeah, so you can just do your factor tree if you're ever not sure. But yeah, so if you have 16 and 2, and then we know 16 is 4 and 4, and then each of those 4s is 2, 2, 2, 2. So do you see how we have 5 2's? And so that answer just ends up becoming what? 2. So anytime you have a group, each group just represents one of those numbers, right? Okay, so now it says find the real square roots of these numbers. So on these, they are, if you're taking a square root, what's the index for the number? It's the root. So in this case, a square root would mean what number? 2, right? Okay, So that means that we are taking the square root of 0.01. Now, if your index is 2, they don't write the 2. Okay? If it's anything other than 2, then they will write it. Does anybody have any idea what the square root of this number is? Okay. Do you guys know what the name of this decimal is? Like if you were to say it out loud? 0.01. What place is this in? Hundreds. This is really 100. Did you guys know that? Because it's in the hundreds place, and that number there is 1, right? If you wanted to rewrite this like as a fraction, this would be 1 over 100. Because it goes out to the hundreds place, so it's 1 over 100. So what would be the square root of 100? 10. So does anybody have an idea what the answer might end up being? 1/10, or as a decimal, it would be what? 0.1. Okay, now remember how we talked about, it says that back up here. So right now we're dealing with an even, right? If the number underneath here, if b is positive, okay, then there are 2 real nth roots of b. So that means that this is going to have 2 answers. So it's going to be a positive and a negative 0.1. The reason for this is if you were to go back and square a negative 0.1, would it make a positive? Yeah. And so that's why you could end up having a positive or a negative value. Yes.
So when it's like you get a positive, I mean a negative, like you're also positive.
And we're going to do a lot of practicing with this. I'm going to have you write notes as to why it is the way it is. But when you're dealing with even roots, it will end up being positive or negative when you take the root of it, oftentimes, but then not always. So we'll kind of talk through it. And again, if you have an even root and you square it, like so if I'm taking 0.1 and I square it, it makes a positive. Does that make sense? So whether the answer was negative or positive, it'll end up making a positive answer. Okay? But on this one, when I take the square root of a negative 1, is that going to give me a real answer?
Yes.
No, it would end up being an imaginary number, right? So we're just going to put no real roots, because right now we're only finding real roots. We're not going to be looking at our imaginary roots. So this answer is no real roots. Okay, so the next one we have is 36 over 121. So we're taking the square root of 36 over 121. What does 36 break down to be? Good, 6 and 6, so that's a pair of sixes, and then 121 is 11 and 11. So when we write this, how should I end up writing it? Plus or minus 6 over 11. Good.
You just take away the root.
Say that one more time.
Take away the root since like you've already taken it.
So since this is a square root, you need 2 in order to take something out of the root, and then there wasn't anything left over. Okay? Okay, so each of these words are important. We've already kind of talked about index is the number that is in your root, the number that you're like taking the root of. The number inside your root, that is called a, thank you, radicand. And then you have your radical sign. Okay. What is each, and notice again how it says, what is each real number root? So A, what do you think?
Negative 3.
-3. Good. And again, if you want to kind of see this broken down here, -27 is really -3 times -3 times -3. And so we have a group of -3s, so my answer is -3. Okay, what do you notice about B?
The index is even.
Index is even, so what does that tell us? If there's a negative underneath, the answer is going to be, okay, no real roots. Now, this next one is a little bit different, and another thing I want to talk to you about is back here when I got these pluses and minuses, I was making the roots. It didn't actually start with a root. That is when you get your pluses and minuses. Here, when they already have the root there, it's not going to be pluses and minuses. Okay? Also, this one is kind of messed up, written weird. The radical should be over the whole thing, and that extra parentheses shouldn't be there. So you know how order of operations, we do parentheses first, right? And so within this problem, because you have these parentheses and stuff under the root, you would actually simplify that first. So what is -7 squared? +49. So this is really the square root of +49 and not a square root of a negative number. Does that make sense? Okay, and so what's the square root of 49? 7. Okay, and this one is only going to be 7 because our root was already there. So it's just going to be that positive number. Back here we're having the pluses or minuses because if you were to have these values and square them, you could get this answer by the positive or the negative value. So basically, anytime you're making a root, you're going to use the plus or minus on even roots. Anytime you don't make the root, it's already there. It's just going to be the positive value. Okay? And then what about D? Good. And why are there no real roots?
Because it's squared.
Very good. It has an even index and it's a negative inside. Okay. Does everybody have this? Are we ready to move on? Are there questions before we move on?
Wait, so why is number,
It's an even index because it's a square root and there's a negative inside. So that would actually be an imaginary number and we're only talking about real numbers. Okay? All right. Okay, so basically, whenever your index is odd, things are much easier, just so you know, because you can have a negative answer, you can have a positive answer, all this stuff. It works out really nice. If, though, n is even, things get more complicated, because how we talked about if there's a negative under the root, first of all, there would be no answer because there's no real roots. Also, if you have a variable underneath the root, you have to use absolute value bars sometimes. This is where I feel like it gets a little confusing, and so I'm going to try to be very specific to help you guys out, and we're going to write down why we're using absolute value bars or why we're not using them, because it's an important part of your answer. And the reason is because when we have variables, variables can be positives or negatives, right? So if you put an absolute value bar around it, no matter what value you put in for that variable, you would take the absolute value of it, which would end up making it a positive. Okay, and that's why we're using it, is because if you have a variable and it's negative and it's under an even root, you would end up getting an imaginary number, which is not real. So if we have the absolute value bars, it guarantees that that value is going to end up being positive. Okay, so I'm going to write some notes here to the side that I want you guys to write as well. Okay, so when you need absolute value bars, notice that it says n has to be even. So that means you need an even root and an even power inside. If you have an even root here and an odd power inside, you don't have to worry about using absolute values. Okay, so I'm going to write here both root, or maybe I should have put actually both index and power need to be even. Okay. Now I'm going to put when pulled out. So like you know how you get your group and you pull it out? Okay. So I'm going to put when out of the radical if the power is even, no absolute value is needed. Why would that be the case? Because if you have a negative number to an even power, what happens to that negative? It turns into a positive. So the only time you actually need the absolute value bars is when you pull out a number and you end up with like an odd root, or I mean an odd exponent when you pull it out. Okay? And so we'll talk through this through examples, but I think it'll be easier as we do examples. So first of all on A, let me go back here. Okay, so A, we have the square root of 81 x to the 4th. So 81 breaks down to what?
9.
Okay, 9 and 9, so we have a pair of 9s. Okay, now notice here, this is an even index and it's an even power. So there is a chance I'm going to need absolute value bars, depending on what it looks like when it's pulled out. Now, 8x to the 4th, how many groups would I have? 2. And I like to write them out like this. So I have x squared, that's a group, and I have another x squared, that's another group. You could write out 4 x's if you want to, but we need 2 x's to make one group, right? And so that's why I just put x squared, that's 2 groups, and if I were to add these together, that goes back to your 4. Right? So how do I end up writing? Go ahead.
We're pretty much computing what goes into x again.
So I'm just kind of separating x to the 4th into how many groups that will make that can come out of the radical. Okay? So how would I end up writing this answer? So whenever, because this is a square root, you need 2 things to make one group, right? So how I have 2 9s, when I bring that out, it actually just becomes a what? A 9, right? Now this x squared, it's a group, but when you bring it out, it actually just becomes an x. But I have 2 groups, so that means I'm going to end up with x squared. Okay, so you know how we said that there's a chance that I might need absolute value bars around my variable. If x ended up being a negative number, and I squared it, it would end up making a positive. So I do not need absolute value bars around this, okay? And so I'm gonna kind of write out in words what is going on here, okay? So we had an even root and even power. But no absolute value is needed because if x is positive or negative, once it is squared, it will always be positive. And I just kind of wrote this example, like let's say x was 3, well 3 squared gives you 9. Well, let's say x was negative 3. Well, negative 3 squared is still going to give you 9. So either way, the reason why when you end up with an even root on the outside, you don't need the absolute value, or an even exponent, sorry, If you end up with an even exponent on the outside, you don't need to use the absolute value bars because no matter what, even if it was a negative, it would end up being positive. Okay, does everybody have that? All right. So I'm going to kind of draw a squiggly line to keep these separate. Okay, so next example, it's an odd index or odd root. So that means I don't have to worry about absolute values at all. Okay, which makes my life slightly easier. Okay, so in order to bring something out, it needs to have 3 of the group, correct? So how many groups? How many I need a to the third. How many of those can I end up making? 4. So 1, 2, 3, 4. And if you add those up, that makes 12, correct? Well, because my index right here is 3, I need 3 for every group, right? And so I was writing, if you were to add these up, 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. So all of these add to make 12. When I bring them out, it'll end up being a to the 4th. But each of my groups are a to the 3rd. But I end up with 4 groups, right? And so how many groups would I have for b to the 15th? How would I write those ones? 5, right. And so you'll end up with shortcuts, which are fine. But I'm just going to write this out so we kind of see what's going on. So again, if you were to add all those up, there's a total of 15 B's, but I have 5 groups of 3. Okay, so we would write this answer as a to the 4th, b to the 5th. Because remember, every group just makes 1 of that number and 1 of that letter. And then I'm just going to write here, no absolute value needed because it is an odd index. And I'm going to put index slash root. If I say root or index, those mean the same thing. Okay, so far so good? All right, so this next one has an even index. So we have to think about absolute values on this one, okay? X to the 12th, how am I gonna write my groups? How many groups will I end up having? 3. So I'm just gonna write this out. So we have x to the 4th, x to the 4th, x to the 4th, x, no, just kidding. Right? So each of these groups need 4 of them because my index is 4, right? And then the y, we have y to the 4th, and I'll end up with 4 of those, right? Because 4 times 4 ends up making my 16. Okay, so when you're worried about absolute values, you are looking at your index and your original powers. Do you see how all those are even? So when they come out, if I end up with an odd exponent, I need absolute values around it. Because if it was a negative number and an odd exponent, that would end up making a negative number, which we can't have. Because a negative number under the root would be imaginary, not real. Okay, and when you have a variable, you never know what it is. Okay, so in this case, when I bring this out, that's going to be x to what power? X to the 3rd. So do you think I'm going to need absolute values around that? Yes. Because if x was a negative number, if I took a negative to the 3rd power, it would end up making a negative answer. And we need it to be positive. Okay? Now for the y's, y will end up being y to what power? To the 4th. Now if this was a negative number and you took it to the 4th power, it would still make a positive. So this one is okay without an absolute value. Does that make sense? Okay, so let's go ahead and write it out. It's kind of a lot of words. So you need, so even root, or should I put even index? It doesn't matter. Okay, write what makes sense to you. Even root and even power I'm trying to decide how I wanted, this doesn't sound right. So even root and even power, absolute values, or absolute value needed if answer is an odd power.
For B,
Yes.
would B to the fifth be absolute value?
No, why not?
Because the index is out.
The index is 3. So anytime your index is originally odd, you don't have to think about anything extra. When your index is even, inside those the exponents have to be even. And then if it comes out and it's odd, you need absolute values. Okay? So even root and even power, absolute value needed if answer is an odd power. Does that make sense? Do we need to write more than that? Is that okay? So we don't need absolute values because this one has a fourth power, which would always end up being positive. Okay, questions?